The chloride ion is the anion class. It is formed when the element chlorine gains an electron or when a compound such as hydrogen chloride is dissolved in water or other polar solvents. Chloride salts such as sodium chloride are often very soluble in water. It is an essential electrolyte located in all body fluids responsible for maintaining acid-base balance, transmitting nerve impulses and regulating fluid in and out of cells. The word chloride can also form part of the name of chemical compounds in which one or more chlorine atoms are covalently bonded. For example, methyl chloride, more commonly called chloromethane, is an organic compound with a covalent CCl bond. It is not a source of chloride ion. Electronic properties: chloride is much larger than a chlorine atom, 167 and 99 pm, respectively. The ion is colorless and diamagnetic. In aqueous solution, it is highly solvated, being bound by the protic end of the water molecules. Occurrence in nature: seawater contains 1.94% chloride. Some chloride-containing minerals include the chlorides of sodium, potassium, and magnesium, hydrated MgCl2. Called serum chloride, the concentration of chloride in the blood is regulated by the kidneys. The chloride ion is a structural component of some proteins, for example, it is present in the amylase enzyme. Role in commerce: the chloralkali industry is a major consumer of the world's energy budget. This process converts sodium chloride into chlorine and sodium hydroxide, which are used to make many other materials and chemicals. The process involves two parallel reactions: 2 Cl-Cl, 2 plus 2A Euro, 2 hours. 2O plus 2A Euro H2 plus 2O Euro. Water quality and processing: another major application involving chloride is desalination, which involves the energy-intensive removal of chloride salts to give potable water. In the petroleum industry, the chlorides are a closely monitored constituent of the mud system. An increase of the chlorides in the mud system may be an indication of drilling into a high-pressure saltwater formation. Its increase can also indicate the poor quality of a target sand. Chloride is also a useful and reliable chemical indicator of river/groundwater fecal contamination, as chloride is a non-reactive solute and ubiquitous to sewage and potable water. Many water-regulating companies around the world utilize chloride to check the contamination levels of the rivers and potable water sources. Domestic uses: chloride salts such as sodium chloride are used to preserve food. Corrosion: the presence of chlorides, for example in seawater, significantly aggravates the conditions for pitting corrosion of most metals by enhancing the formation and growth of the pits through an autocatalytic process. Reactions of chloride: chloride can be oxidized but not reduced. The first oxidation, as employed in the chloralkali process, is conversion to chlorine gas. Chlorine can be further oxidized to other oxides and oxyanions including hypochlorite, chlorine dioxide, chlorate, and perchlorate. In terms of its acid-base properties, chloride is a very weak base as indicated by the negative value of the pKa of hydrochloric acid. Chloride can be protonated by strong acids, such as sulfuric acid, NaCl plus H2SO4 and NaHSO4 plus HCl. Ionic chloride salts reaction with other salts to exchange anions. The presence of chloride is often detected by its formation of an insoluble silver chloride upon treatment with silver ion, Cla plus Ag plus AgCl. Examples: an example is table salt, which is sodium chloride with the chemical formula NaCl. In water, it dissociates into Na plus and Cl ions. Salts such as calcium chloride, magnesium chloride, potassium chloride have varied uses ranging from medical treatments to cement formation. Another example is calcium chloride with the chemical formula CaCl2. Calcium chloride is a salt that is marketed in pellet form for removing dampness from rooms. Calcium chloride is also used for maintaining unpaved roads and for fortifying road bases for new construction. In addition, calcium chloride is widely used as a de-icer since it is effective in lowering the melting point when applied to ice. Examples of covalently bonded chlorides are phosphorus trichloride, phosphorus pentachloride, and thionyl chloride, all three of which reactive chlorinating reagents that have been used in a laboratory. Other oxyanions, chlorine can assume oxidation states of a 1, +1, +3, +5, or +7. Several neutral chlorine oxides are also known. See also, halide, renal chloride reabsorption, references.